Hold on, guys. Woo. A little behind the scenes there. A little BTS. Okay. So today these are the notes for 5.3 independent and dependent variable. This is a little different from what the types of stuff we've done so far. There's a lot more, there's not much math, but a lot more words and kind of thinking about how numbers work together. So I bet you got this though. I know you got this. Okay, so let's get after it. Let's start by putting our name and class period at the top. Also, I know that this looks like a lot of notes. It is 5 pages, but you're going to be fine. Let me wait for everybody to have their little mini heart attacks here. This is actually 2 vocabulary words and then 5 problems. That's it. So the reason that it takes so many pages is just because we've got some graphs and some tables, and those take up more space. So that's it. It's not that bad at all. Okay, so first off, we're going to talk about independent and dependent variables. You may have already talked about these in science class, actually, if you're talking about experiments ever and trying to figure out, hey, what can I change? And then I'm changing my output and stuff like that. So first off, an independent variable is the domain. It is the input, so it's what we put into our function or into our equation. It's and it affects the dependent variable. So, also since it's my domain and it's my input, I know it's my x values. And I know it's going to go on my x-axis, which is my horizontal axis. We're going to do examples here in just a minute. Let's get these filled in first. We're going to do it, like I said, a little bit different than we typically do. So let's see. Next up, we have dependent variables. So the dependent variable is the range, and that is our output. So remember we talked about in function notation where our x is what we put in and then our output is kind of what we get out. So after we do all the stuff, so either we square it or we multiply it by 2 and add 1 or whatever we're doing. So it's our range. It's how high or low our graph can go or our values can go. It's the output, and it is affected by the independent variable. It also, we could say, instead of affected by, we could say it depends on. So we could say that the dependent variable depends on, so it relies on. We don't know what our dependent variable value is until we know what our independent is. And then this is our y values. Again, because it's the range. Okay, so let's think of a really easy example, I think, for this one is to think about the weather outside. The weather outside is bright. Okay, so the independent variable is kind of, it just changes. Whatever it is, it affects things that we do, correct? So I could say that the weather outside the weather outside is my independent variable. My dependent variable, what depends on that, what relies on that, what is the output once I know my input of the weather outside, once I wake up in the morning and check the weather or whatever I do, then my output is, a lot of times it's what clothes I wear. So that's an example. Ooh, that's the strangest eye ever. Okay, so that's an example of how we can think about independent variables and then dependent variables. The weather outside can change and do whatever it wants. I react to that. My clothes depend on what the weather is doing outside. I don't get dressed and then the weather says, oh, she's wearing shorts and a t-shirt, it needs to be hot. That's not how it goes. So let's look at some examples and kind of think through some stuff here. Like I said, today's a little bit more thinky than it is mathy. So example one, our directions here are to decide if these are functions or not. We're actually not going to graph. I forgot to take this off of there. We're actually just going to talk about the dependent and independent variables here. So once a month, Jack drives 215 miles on the interstate to visit his grandfather. He loves his grandfather. Which quantity, value, amount, quantity means value or amount, is independent and which is dependent between, so it's giving us the two choices, the amount of time it takes Jack to get to his grandfather's house, so the length of the trip in time, or the speed at which he drives. So which one of these affects the other one, right? So I'm going to think about it this way. Which one depends on the other one? Which one, if I'm calling up and my grandfather going to ask me, is he going to say, what time are you going to get here? Or is he going to say, how fast are you going to go? He wants to know the time. He wants to know the result. But that to figure out that time, how long is it going to take me? I have to first think about the speed. I have to think, how fast am I going to drive? Is there a bunch of traffic? Am I going to be going slow? Is it going to take me longer? Or am I going to go, am I going to be able to go super fast? Have they raised the speed limit? Do I know there's no cops? All this stuff. And now I know that my speed is going to be able to go fast, and that's going to make my time go down. So my time is dependent. It depends on how fast I go. So I know that the amount of time it takes is my dependent because it depends on the time the trip takes depends on the speed Jack drives. And I know sometimes you might say, well, I want this trip to go faster, so I'm going to change my speed and I'm going to go faster because I want to go faster. But it's still the thing that is going to be the output that is always going to rely on the other is the time that the trip takes is always going to depend on the speed. So you might think you can control the speed, but sometimes, traffic comes up or, there's terrible weather and you have to slow down, all sorts of that stuff. So the time, so we're going to use a statement to describe this using each of these factors and the phrase depends on. So the time, and guys, I was an English teacher for a long time. I know that we put a capital letter at the beginning of a sentence. Excellent. Love it. So the time the trip takes depends on the time the trip takes, I already used depends on, it depends on the speed Jack drives. Okay, go ahead and pause if you need to make sure you've got that filled out. So the speed, so the independent variable is the speed that Jack drives, and then the dependent is the time the trip takes. I don't say, oh, my trip is going to take 4 hours, so then I drive a certain speed. That's not how it goes. It might be how you try to make it go, but that's not how it goes. It's always going to be that I go this speed, and the result is how much time it takes. Okay. Go ahead and meet me on example 2. Okay. Example 2. Mark needs $35 per day for meals on his business trip. How much money will he need for a 4-day trip? Which quantity is independent and which is dependent between the total amount of money Mark needs for food on the trip and the length of the trip in days? Now, I know I told you guys, this is not a mathy day. This is algebra, but we're not doing a lot of math. So they give us these numbers and stuff, but they're not asking us to actually solve it. They're asking us to think about, okay, so what's depending on what here? Okay. So I know that I have a total amount of money that I need, and I know that I have a length of my trip in days. Okay. So let's think about how this goes. Do you think that Mark, the way this is presented, it says that he has a 4-day trip. So when he goes and says, hey, I need my money for my trip, they're going to say, okay, not how much money do you need? They're going to say, how long is your trip? So the independent variable here is the length of the trip okay? And then the dependent, so the thing that depends on that is how much money he gets. Okay? So the company's not going to know how much money to give him for his food until they know how many days his trip is, right? It's a little different than if you're budgeting for yourself and like you and your family are planning and you're like, hey, we only have this much money. Then it kind of switches it a little bit. But in this situation, he knows that he gets $35 per day. He gets a certain amount per day, and he has a 4-day business trip. So the independent variable, the thing that's going to be able to change in there is the length of the trip in days. Okay, that 35 is always going to stay. And that length of the trip in days can change. Our input can change. And then our output is going to be the total amount of money for food. So let's use it. Let's use these two phrases and the phrase depends on. And a capital letter at the beginning, please. So the total amount of money for food depends on the length sorry, I forgot how to spell length there for a minute. Length of the trip in days. So the total amount of money for food depends on the length of the trip in days. This is actually one we've got a little bit of room, so I'm going to go ahead and actually do just a little sketch graph. So we can do sketch graphs in algebra to think about how things are related. So I know, okay, I know that my x value, my independent value variable, is the length of the trip in days. So I'm going to say number of days. Okay. And I know that my dependent variable, my output, my y values are the total amount of money. And I'm just going to put a little dollar sign there. Okay. So I have a question. Let's think about this. We know that this is 0, 0, right? And these numbers are going up and these numbers are going up. Let's think about this. If I go on a 0-day trip, how much money are they going to give me for food? 0. Perfect. There's our starting point. if I go, let's say I go on a trip for a number of days, the amount of money, so as my X value goes up, my Y value is also going to go up. So I might end up there. Well, then if I go on a little bit longer trip, they're going to give me a little bit more money. More days, more money. So this is actually just a little sketch here. Remember, no numbers at all. A little sketch here to think about. Hey, the more days, the more money. Okay. Make sure you're caught up on that one. Not only a capital, but a period at the end, please. Example 3. Oh boy, now we've got a graph. Now we have a graph. This is crush versus impact speed. I'm going to give you guys a little information here. This is looking at cars and car wrecks and thinking about, okay, if I'm going a certain speed, how much is the front end of my car, and I hit something, how much is the front end of my car going to crush up in inches? So if I'm going 10 miles an hour when I hit something, it's only going to crush up, hold up, I need to figure out what color I'm on. We all know that is critical, important information. Okay, so I know that if I'm going 10 miles an hour when I crash, the front end of my car is going to crush in about 5 inches. If I'm going 20 miles an hour, front end of my car is going to crush in a little bit more, right? 30, a little bit more. Okay? So I need to think about my independent and my dependent variable. Well, first of all, I know some things. I know that always and forever, the horizontal axis is going to be my x-axis, and the vertical axis is going to be my y-axis. Okay? I know also that my independent variable is my x. My x is my independent variable. It's my input. It's what I put in. I can't say, okay, I want my car to crush 15 inches, so I'm very carefully going to drive this exact speed when I crash it. That's not how life works, right? We crash our car and then we're like, well, that happened. That's weird, unfortunately. And hopefully you're still alive to say, well, that happened. That's weird. So what decides the situation here is how fast our car is going. So the independent variable is, let me find my notes here. I want to make sure I'm getting them correctly. Okay, so the independent variable is this x-axis. It's my speed. And then the dependent variable is my y-axis. It's my crush. It's how much my car crushes. Okay. So let's use the phrase depends on. Remember, this depends on that. Depend. Okay. So statement using the phrase depends. The amount of crush depends on the speed. I said that weird. So the amount of crush depends on the speed. Easy. Okay, again, capital and period. I just can't let it go, y'all. Okay, I know we know. Okay, next up. Oh, this is one. Oh, no, this one's not too bad. Okay, so this is a table. So we had a graph, now we have a table. And if you remember, we talked about how when we have a table like this, what am I looking for? This pen, that's what I'm looking for. When we have a table, these are our x values and these are our y values. Okay, so already I don't even really have to think about this one too much before I can already fill in my independent and dependent, and then I can kind of think through and check myself. Because I know that x values are my independent variables. They're my input. input independent. Get it? See? Okay. So my X values is my time in seconds. Okay. And my water temperature is my dependent variable. So the water temperature depends on the time in seconds. So the water temperature okay. And let's think about this a little bit. We know that we have our time. We know that we have our temperature. Okay. So we know that time is always going to get bigger, right? Time marches on. So our time is actually 0, 10, 20, 30. That's getting bigger and bigger and bigger, right? What's happening to our water temperature, though? It starts out at 15, 16, 18, 22, 28, 32, 37. Oh, our water temperature is actually warming up too. So there's a little sketch graph. Because I know that the longer it's in here, the higher that temperature gets. So we could sit and think through and try to figure out some situations. Maybe we're boiling water. Maybe we're making sun tea in August. Maybe Miss McNabb forgot her bottle of water in the car in August. A lot of August involved here. So let's go ahead and use our time or our phrases here, and then depends on. So remember the dependent variable depends on the independent variable. So the water temperature depends on the time in seconds. Okay, and we can just kind of use our little brains here to figure out, hey, it's heating up, so some sort of heat is being applied to the water here. But we don't have to know exactly what's happening to figure out our independent and dependent variables. Because I'm not sitting here going, okay, my water is 28 degrees, so let me make sure that it's in there for 40 seconds. That's not how it works. It goes in for 40 seconds, and then you check the temperature, and it's 28 degrees. That's how it works, okay? So, last but not least, this one's not a super fun one, I know, guys, but I do put it in here because it is important for us to know and think about. This is actually some true information. This is fatal accidents by driving age. Can't imagine why I would go over this with freshmen. If you think about, and yeah, this is real actual information from 1997. So if you think about the word fatal, it does mean somebody died. So what we're thinking about here is the age of a driver, okay? And then the number of fatal accidents. So if we just look at this group of the entire population, right, that's this age, how many actual fatal accidents involved people those age, or involved people that age, or in that age group. So let's think about this. I know that my X value is my input. It's my independent variable. So my independent variable is the age of the driver in years. So the age of drivers. Okay. And my dependent variable, the thing that affects that, or that is affected by that, is my Y value. It's my output. And that is my number of fatal accidents. Okay. So here we know that the number of fatal accidents depends on, there is a relationship there, the age of the driver. Now, is that saying that there are no fatal accidents with old people? No, old people have car wrecks that end up killing people, but we're saying that more happen the younger you are. Okay? So the number of fatal accidents depends on the age of drivers. Okay. And that's just, I mean, that is an important thing to think about. You know, obviously, when we have wrecks, we don't sit there and think about, oh, how old am I? Okay, well, that can decide if this was a fatal accident or not. No, we don't take our input here, and our ages are, we don't, sorry. Yeah, we don't take our age as our output and then think about, oh, well, how many accidents did I want to have? That's not how it goes. It goes the other way around. So, and that isn't important because we do notice a different trend here. If I want to do a bit of a sketch graph, even though they already gave us kind of one, we can see a little bit of a trend here. We can see that age and just, we'll just say number of wrecks. Okay. So we can see that the older you get, the less number of fatal wrecks you have. So whereas before we've started down here, we've said, hey, you know, if you're young, you're not having any fatal wrecks. Now we know that there's a number 16 and all that stuff, but technically what we know is that it actually goes in that direction, right? Because here you've got some younger people, the age is smaller, is closer to this 0, but they've actually got the highest number of fatal accidents. So we have this type of graph here. And that tells us that, you know, probably if you're a younger driver, please be super, super careful. That's it for right now on these notes. Make sure you get caught up, go back, catch up, whatever you need, and I hope you have a great day. Thanks. Bye.